This is a cloud-native 5G core service-based architecture setup in UDF. In this setup, I'm using the Free5g version 3.0.5. The environment will be running on Kubernetes 1.19.5 with a multi-node cluster. It's running Calico CNI Multis, and I'm using UE RANSIM to simulate connections from the phone, user equipment, and a G-Node B simulator. In the environment, I have F5 career grade net as well. All the resources demonstrated in this UDF will be available in this 2 Git repository. A special credit to the public GitHubs information from these 2 sites. The objective of this UDF is actually to have a baseline 5G Core SBA environment so that we are able to develop other services on top. For example, I can add SPK on top of it, or Aspen Mesh, or Nginx Service Mesh, or even Volterra, so that we can develop additional services on top of this environment. There are 2 patterns that I've developed in this UDF. This is the first pattern. Let me go through quickly how all these things will hook up. So basically, I had one of the Ubuntu desktop act as the user equipment and the G-Node B. So the UE RAN simulator is going to run on this Ubuntu desktop server. And this Ubuntu desktop server, there's no default gateway setup. So what the expectation here is that once this 5G simulated UE able to associate sessions with the SMF, this 5G phone will be able to get to the internet via the UPF setup here. So in the edge cloud, there's a UPF setup in Kubernetes, and there's a couple of applications running at the edge. This is the private or public cloud 5G core, where you have all the respective SBI interface connected with the SBA service-based architecture setup. And there's a DN networks which have the F5 CGNet. So the Windows desktop here is so that because there's no default gateway, you can either RDP directly to the Ubuntu desktop, or you can go via the Windows. And this Windows jump host will be used as a clients to connect to the web UIs to set up the IMSI, the sessions, the subscriber. This is the first pattern. In the pattern 2, the setup is similar but it's slightly different. So for pattern 2, what I will have here is that I have a branching UPF here, which is also on the edge cloud. So there's no, what happened here is that the associations will be passed through from the UPF, the branching UPF, to the anchor UPF via the N9 interface, and to the F5 CGNet to the internet. So this is a quick walkthrough of the environment. Looks forward for the individual demo videos for pattern 1 and pattern 2. Stay tuned. Thank you. This is just an example on if you laid Aspen Mesh on top of the 5G Core SBA. This is the service graph that you can visualize on all the connectivity between all the respective services within the SBA. This is just one of the example. This Aspen Mesh is not been installed in this baseline 5G core. So yeah, please feel free to clone this baseline and then add Aspen Mesh or NSM or SPK or any others 5G functions that you would like to run on top of it. Thank you.